Okay, ladies and gentlemen, I'm going to try to make a video here doing some more optimization questions from that package of 8 questions. The questions that I'm going to work at are all on page 5. Here is question number 1 from page 5. And if you read the question, it'll say that the area of the page, the outside page, x times y in this case, the big rectangle, has an area of 320 square centimeters. And then they say you're going to do some writing on the inside rectangle. This inside rectangle is where all the writing is going to be. And it has margins around it of 2, 2, 2, and at the bottom 3. So we want to find the area of this rectangle on the inside, that the dimensions of the rectangle that will maximize the area. So looking at this first one here, we see that all across the top is x, and we're going to take away 2 from each side. So x minus 4 will be the width of this rectangle. And by the same logic, if the whole part is y and we take 3 from the bottom and 2 from the top, y minus 5 will be the length of this inside rectangle. Well, we want to maximize the area of this inside rectangle, so we're going to say area equals x minus 4 times y minus 5. And we're going to take our known relationship and we're going to solve it for y, for example, and we're going to substitute that known relationship right in there. So your formula for area will look like this. A equals x minus 4 times 320 over x minus 5. So we're going to simplify that as much as we can. Then we'll take its derivative and set it equal to 0. So let's expand it using FOIL. We get 320 minus 5x minus 1280 over x plus 20. Simplifying that a little bit more, I've got 340 minus 5x, and this term I'm going to write as minus 1280 x to the minus 1. So there's my simplified form of my function, and now I'm going to take its derivative, a prime, and then set it equal to 0. So let's simplify that a bit. A prime equals negative 5 plus 1280 over x squared. And then I'll find a common denominator for this one. Multiply this by x squared over x squared. So I get my derivative to be a prime equals negative 5x squared plus 1280 all over x squared. So our job is now to take that derivative, a prime, and set it equal to 0. So if we're going to set it equal to 0, we only need to worry about the numerator. So when does minus 5x squared plus 1280 equal 0? We can transpose the 1280. We can divide by negative 5. And we get x squared equals 256. So x would equal plus or minus the square root of 256. Well, for us in our situation, x is going to be a positive. We are only interested in the positive square root. X equals 16. Knowing x equals 16, we can substitute that value back in here to find out what y is. Y equals 320 divided by 16. Y equals 20. So the dimensions of the inside rectangle, the printed part of the page, are going to be 16 subtract 4 and then 20 subtract 5. The dimensions of the outside page, and I think that's what they ask, is going to be 16 centimeters by 20 centimeters. We want to compare question number 1 to number 2. Number 2 reads a little bit differently. It has the inside area given. So if you take a look at question number 2 carefully, it tells you that the inside rectangle, a page with printed area of 378. So this time I want you to notice that I used X and Y for the inside part because X times Y equals 378. They give you this area and they want you to minimize the dimensions of the page. So what are our dimensions of our outside rectangle going to be? It's kind of like going backwards. This time they give us the inside X, and this time we're going to add 3 to the left and to the right. So X plus 6 will be this dimension right here. And this one we're adding 3 to the top and 4 to the bottom. So this one becomes Y plus 7. So now we have A equals X plus 6 times Y plus 7. And we'll take our known relationship up here and solve it for one of the variables. And we'll plug that right in there. So our area formula now is X plus 6 times 378 over X plus 7. We'll expand those out like we did the other one. The main difference between this question and number 1 is that X times Y represents the inside rectangle. In the previous question, X and Y were the dimensions of the outside rectangle. So read the questions carefully and see if you can see the difference. So we have A equals 378 plus 7X plus 2,268 over X plus 42. So A equals 420 plus 7X plus 2,268 X to the negative 1. And the rest of the steps are the same, so I'll go through those fairly quickly. A prime equals 7 minus 2,268 X to the minus 2. So A prime equals 7 subtract 2,268 over X squared. Find a common denominator just to make it a nice neat fraction that you can easily set equal to 0. So continuing it on up here, A prime equals 7x squared minus 2,268 divided by x squared. So A prime equals 0 when the numerator equals 0. So 7x squared equals 2,268. X squared equals 2,268 divided by 7. So x squared equals 324. X is equal to the square root of 324. So x is equal to 18, I think. Sure, x equals 18. And if x is 18, y equals 378 divided by 18. I'm just substituting that up in here to figure out the dimension y. And 378 divided by 18 gives you 21. Now read this question carefully. Find the dimensions of the entire page. So they don't want the inside rectangle, they want the outside rectangle. So the outside rectangle is x plus 6, so 18 plus 6 or 24, and y plus 7, which is 21 plus 7 or 28. So that makes the dimensions 24 centimeters by 28 centimeters, the entire page. The next question that we look at is pretty famous. We do quite a few of these inscribed shapes. This one may be hard for you to visualize, but hopefully the diagram will help a little bit. You see a sphere on the outside, like a basketball or a volleyball, and inside it you've got a cylinder. So you've got to imagine inside a cylinder, wedged inside the basketball or volleyball. This is maybe an easier picture because it's 2 dimensions. It represents the cross section. So this is just a rectangle with a circle in it, and that's what you want to visualize when you look at this. So the radius for this question says the radius of the sphere is 6. So you want to take the radius and you want to draw it from the center of the sphere all the way out to the outside edge of the ball, but you make sure it touches the corner up here like this, creating a right angled triangle. So then we have the radius of the cylinder to be x, half the height of the cylinder to be y, and the radius of the sphere to be 6. So it creates a Pythagorean theorem relationship where x squared plus y squared equals 6 squared, x squared plus y squared equals 36. Well, that's our known relationship. We want to try and maximize the volume of the cylinder. The formula for volume of a cylinder is pi r squared h, and for us, the radius of the cylinder is x, and the height of the cylinder will be 2y. So V equals 2 pi x squared y. In this question, it really matters what you solve for. We've got x's and y's in there, but the x is squared, and I have x squared over here. So if you look at these two, I'm going to solve for x squared, and that way I don't need to worry about square roots when I substitute in. So x squared equals 36 minus y squared, and I don't need to go any further. This is a much better variable to solve for than y. So I'm going to plug that in and get my volume formula. Volume formula be 2 times pi, and what's x squared equal to? 36 minus y squared times this y at the end. When I expand that all out, 2 pi y times 36 gives me 72 pi y, minus 2 pi times y times minus y squared gives me minus 2 pi y cubed. And that's a really easy formula now to take the derivative of. V prime will equal 72 pi minus 6 pi y squared. V prime equals 0 means 72 pi minus 6 pi y squared equals 0, minus 6 pi y squared equals negative 72 pi. Y squared equals negative 72 pi over negative 6 pi. So y squared equals 12. Y will equal the square root of 12, and that's 2 square root of 3. So that's the value of y. We've got to make sure we answer the question. It says find the cylinder of greatest volume. What are the dimensions going to be? Well, remember the height was 2y, 2 root 3 times 2, 4 square root 3. That's going to be the height. And the radius is equal to x squared equals 36 minus y squared. So I'm substituting this value right here, right into this expression. So x squared equals 24. X is equal to the square root of 24. And that's 2 square root 6. And there's your radius. So the dimensions of the cylinder are 4 root 3 centimeters for the height and 2 root 6 centimeters for the radius. The last question that I wanted to do, and I don't have enough boards to do it, but at least I can get it started, is question number 6. So here's number 6, and it's another question where it's inscribed. As I read it here, it says you're going to put a cylinder of greatest volume inside a right circular cone. So there's a tin can wedged inside a cone, and it tells us a couple of things about the cone. It says that it has a base diameter of 10 centimeters, so that makes this radius equal to 5. And then we have the height of the cone to be 20. So that's the distance from here to here to be 20. Well, I'm going to look for another right angle triangle inside this cone, and it's going to look like this. It's going to be this part right here and this part right here. So I'm going to call this x and this y, and the ratio of x over y, this little triangle here, is in the same ratio as 5 over 20. So we can cross multiply those and solve for whatever we want. Let's talk about the formula for volume of the cone now. V equals pi r squared h. So, excuse me, I said volume of a cone, I meant volume of a cylinder. What's the volume of the cylinder right here? What's the radius going to be? And the height. Well, this y is the distance from the top of the cylinder up to the top of the cone. The whole distance is 20. The height of the cylinder is really 20, subtract y. Here is 20, take away y from it, and you'll be left with the height of the cylinder. And we're going to cross multiply over here in a moment and solve for y. But this is what I have for volume. 20 pi x squared minus pi x squared y. So I'm going to solve this relationship over here for y. I have 5y equals 20x, and that's done through cross multiplication. So y equals 20x over 5, y equals 4x. Let's take this known relationship and let's plug it in there. So that makes our volume formula equal to 20 pi x squared minus pi x squared times 4x. So volume equals 20 pi x squared minus 4 pi x cubed. So there's our formula. From there, that process is quite a bit easier. The hard work has been done. Take the derivative, 40 pi x minus 12 pi x squared, and then set it equal to 0. So let's see, 40 pi x minus 12 pi x squared equals 0. You can common factor out of 4 pi x from those, and you're left with 10 minus 3x equals 0. If I've got my math right here. So 4 pi x equals 0 means x equals 0 over 4 pi, x equals 0. Or 10 minus 3x equals 0, minus 3x equals minus 10, x equals 10 thirds. So I'll check thirds, that's going to be the radius. And the height of the cylinder is going to be 20 minus y. So there's y, this is 20 minus y, that's going to be the height of the cylinder. So 20 minus y, where y is equal to 4x. So 4 times 10 thirds. (20 minus 40 over 3), that gives you 60 minus 40. So the dimensions of the cylinder are going to be radius 10 over 3 centimeters, I think, and height 20 over 3 centimeters.